Hi everyone, this is Frank, and today I'll be reviewing trapezoids with you guys. The definition of a trapezoid is a quadrilateral with at least one pair of parallel sides, and these sides are not equal. The other variation of trapezoids we'll see in this class is isosceles trapezium, which is a trapezium with equal lengths on the side. Two concepts that were commonly associated with the trapezoid is the area and the mid-segment theorem. And the mid-segment theorem, there's a formula. It is half plus a plus b, which is a and b in this case is just the length of the base, and ab, so it's a sum divided by half. Which means that this line is half the length of the sum of the two bases, and the area is basically the sum of the two bases halved multiplied by the height. Now let's try this on a practice question. This question asks us to find the area of trapezoid ABCD and as well as the length of AC. My plan for this question is in 4 steps. The first step is using the mid-segment theorem that we just learned to find the base, which is B, the longer base, DC. And then my second step is using trig to find the height. And then I will plug in the trapezoid area formula here and find the area of the trapezoid. Then to find diagonal AC, I would use the height we just found and this part of DC to find the diagonal AC. If we look at this formula, we can see that the mid-segment is half of the sum of the two bases. Now, we only know one of the bases, which is the top one, A, which is 11. So we must use the formula. Now, the formula, we know the length of the mid-segment, so we can write 15 is equal to half of 11, which is A, plus the unknown, which is B. Now, if we do some simple calculation, we'll get 30 equals 11 plus B. And if we subtract that, B will be 19. So the next thing we need to find is the height using trig. One cool property of a trapezoid is that its adjacent sides of a trapezoid is supplementary. I want to take notes on that. So we know that this is 120. If A is 120, the adjacent side must be 180 minus 120, which is angle D. And so angle D will be 60. Now all I have to do is use trig, which I won't specify because it's in another video, and we'll find that the height is 6.062. Finally, to find the area, we have to plug in the area formula, which is half base 1 plus base 2 times the height, which is, we found that earlier, and we'll get 90.933. To find the diagonal AC, we have to use Pythag, which I think most of you know, a squared plus b squared equals c squared, and so we use the height and GC. To find GC, we must use trig again, and I've shown the work here. We'll find that DG, the tiny snippet, is 3.5. So to find DG, we just do 19 minus 3.5, which would give us 15.5. So now you just plug in the Pythag formula, and you'll find that AC is 16.643. So here's our answer. The area is 90.933 and the diagonal AC is 16.643. And just to run over the steps again, we first used the mid-segment theorem to find out the longer base, which turns out to be 19. Then we used trig to find the height. Then we plugged it into the area formula, half A plus B times height. A plus B in this case is again the sum of the two bases, and then we use Pythag to find the diagonal of the AC. And I can't stress how much important it is to review your mid-segment theorem again, or go back to the video, and the area of the trapezoid, because those will come up a lot of times in the trapezoid problems. Thank you for watching.